All right, welcome to lesson 4. Today we are continuing with our same standard HE1 about lines being taken to lines, segments to segments, angles to angles, and parallel lines to parallel lines. Today's lesson is all about reflection, so by the end of the lesson you'll be able to perform reflections across lines. You'll know you're successful when you can show that reflections share some of the fundamental properties with translation. So they also map lines to lines, they also map angles to angles, they're distance preserving, things like that. And you should also know that reflections map parallel lines to parallel lines. Okay, let's go ahead and get started with this lesson. All right, to just build some background and kind of discuss what this lesson is going to be about, we're going to walk through this little example. It says, let L be a vertical line. I'll highlight L in yellow. Okay, and let P and A be 2 points not on L, as shown below. So we have P and we have A. They are not on the line. They're just kind of near it. Also, let Q be a point on L. So Q is a point on that line. The black rectangle indicates the border of the paper. Okay? What we're going to do here is we're going to reflect some things across planes. So when you do a reflection, you have to have something you're reflecting across, whether you are reflecting across a line, a point, a shape, whatever. Most of the time we're gonna be reflecting things across a line. All right. And just to remind you, reflecting something is just like mirroring something, right? You think about your reflection in the mirror. That's pretty much what it means. Okay, you just see the same image, just kind of flipped. All right. Sorry, that was my cat. But yeah, so those are words that all mean the same thing. So let's get into a little bit of practice here with this example below. So if I were to reflect this entire image over line L, so line L is going to be basically like my starting place. So that is not going to change. I'm just flipping everything over that line L. This point A is going to now be on this side over here. Okay, I'll label it A prime. Q is not really going to change spots because it's directly on that line, and that line's not going to move, so it's just going to be right on top of itself, Q prime. And then P is going to actually come off of the plane. That'll probably be like over here. That seems about the right distance. And so this will be P prime right here. So that is if we were to reflect over line L. Okay? So again, this shows a reflection over line L. And one thing I really just want to point out to you is that if there's a point on the line we're reflecting over, it doesn't change positions, but everything else is going to just flip positions as if it were in a mirror. So if you think about a mirror, and if you were to put your fingertip and touch that mirror, your fingertip is going to be touching your fingertip, right? Those would be in the same spot, but as you move away, you can see your body. It's kind of like a distance away from that line where it separates the real world from the mirror world, I guess you could say. Okay, let's go ahead and move on. All right, so for exercise 1 and 2, we're going to reflect triangle ABC and figure D across line L, and we want to label the images. So I can see that this point right here, B, is touching this line, so my reflected point, B prime, is also going to be touching that line. It's just going to be right there. So this is B prime. Okay, from there I know that this line kind of goes out a little bit down, and at the end there's another point, and this is going to be the same point that matches here. This is going to be C prime. So there's C, there's C prime. Okay, and then we're going to come up. Be pretty steep. And there's a point right at the top. This is my A prime, right? It matches the point that's up top here. It's a little bit off, but my drawing's not perfect. And then this line just connects back down to B. Or B prime, sorry. So we've done our triangle A prime, B prime, or ABC prime. And then we need to reflect this figure D down here as well. So this one's going to be a little bit harder for me to draw. So this way, this line is going this way. So if I were to flip it, it would be going out this way instead. Okay? And then we have a straight line going up. It's kind of hard to mirror things, but do your best. And then it comes back around. Again, not perfect, but we don't have transparencies. We can't really trace. If you want to trace with your computer, that's up to you. Some people say it like messes up the screen, so again, completely up to you. And this is figure D prime. Okay? It says, which figures were not moved to a new location? So there's only one thing that was not moved to a new location here. Well, I guess two things if you consider the line a figure as well. So line L did not move because that's what we reflected across. Line L. And the only other thing that did not move was point B. Stayed in the same space because it was also on line L. All right? One thing I want you to note is there's no measurements here, but if we were to measure it, our lines would be the same length on both sides. Our angle degrees would be the same length on both sides. And that's because reflections preserve those lengths in those angle measurements. Okay, moving on. All right, exercise 3 and 4, it says reflect the images across line L. I want you to pause this video and try it on your own. Okay, and then press play and you'll see that mine is also reflected once you press play again. So again, pause right now. All right, go ahead and check your work with my work. Again, it's not going to be perfect, but you can be close. We have first this circle over here, and we have this line, J and I connected, or on this side, J prime and I prime connected. Then this triangle, or this angle was flipped over on this side. We have A prime, B prime, C prime. I kept the same measurement, 66 degrees, because it's going to stay the same. Okay? Now, it asks us to use a protractor to measure the angle of ABC. We don't need to do that. Oh, sorry. You should know just from our last slide where I talked about this, the angles are preserved in reflections. So just say it is 6 degrees. Okay. And it says use a ruler to measure the ruler. What do you notice? Well, we don't have a ruler. We're not going to need one. But you should know that if we did, and if this was done perfectly, J prime, I prime is going to be the same length as Ji. Okay? So again, our degrees are preserved and our lengths are preserved when we do reflections. Okay? Let's move on. All right, this one's a little bit more difficult. Go ahead and pause the video and then reflect figure R and that triangle across line L. Okay? And then come back and press play. All right, the first one I did was super easy and I didn't want to even record myself doing it. We have R prime down here. Again, not perfect at all. The next one I'm going to actually do with the video going so that you can see it. So shapes are hard to do reflections with if you're just trying to think of drawing the whole shape at once. It's a lot easier if you focus on one point at a time. So I have E right here. It's about that far away from line L. So my next E, my E prime is going to be right here. F is right here, so it's going to line up, and it's going to be probably about this far away. So this is F prime. And then G is on this side, so my new G is going to be on this side. And this is going to be my G prime. And then I can connect them, E, F, G, and it looks a lot easier, or it is a lot easier than it actually looked before, because I get overwhelmed with those shapes trying to think about reflecting them. that's my suggestion for you. That's a strategy. Just do 1 point at a time. Okay? And that's what it should look like when you have it reflected. Make sure you label your images with primes. All right, moving on. All right, just to go over the basic properties of reflections, they map lines to lines, rays to rays, and segments to segments, and angles to angles. That's just basically saying these measurements, these degrees, they're all going to stay the same. They preserve the lengths, they preserve the measurements. So if you have a measurement on one side of 45 degrees, if it reflected across a line, the other side, it's still going to be 45 degrees, okay? If you had something that is 10 centimeters long on one side, you reflect it across, it's still going to be 10 centimeters long on the other side, okay? Well, let's go ahead and move on. All right, here is your practice to do exercises 6 through 9. It says use the picture to label the unnamed points. So there's a lot of points on here that are not named. Go ahead and label these points now. I'll point them out. We have one right here, one right here, one right here, 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 and here, 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 and I think that's it. So go ahead and all those points I just highlighted, go ahead and label them what they should be. Pause the video and then come back and press play once you have that done. All right, check your points with my points. Make sure you label them correctly. Okay. Sorry about that. The next one is number 7. It says, what's the measure of JKL? So where is JKL? It is right here. JKL. It is going to be this angle right here. What is that measurement? Well, we'll look at our reflected image. What is the measurement of that angle right here? 31 degrees. So angle JKL is 31 degrees. And then ask us to find KIJ. So KIJ is going to be KIJ. So it's going to be this angle right here. And if we look at our reflected image, that angle right there is 28 degrees. And then we have one more, angle ABC. So we have ABC. We're looking for this angle right here. If we look on our reflected side, that is 150 degrees. And how do we know this? Because reflections preserve angles. All right. Number 8, it says, what is the length of segment reflection FH? So let's look for FH real quick. Looks like here's FH, and we're looking for the length of the reflection of FH. So FH prime. What would be that length? Well, this one is 4 units. So this is also going to be 4 units. How do we know? Reflections preserve lengths. Here's our explanation right here, same as before. And then lastly it says, what is the location of reflection D? Well, we didn't really do this one here because this was on our line. So it is in the same spot. So D and D prime are in the same spot. We'll label that D prime as well. Okay. And so hopefully all this made sense to you. If it did, you're going to do great on the exit ticket. Let's go ahead and move into the closure, and then you'll be done. All right, our lesson summary is that a reflection is another type of basic rigid motion. We've already talked about translations, which are slides. Reflections are mirrors. A reflection across a line maps one half of the plane to the other half, blah, blah. Yeah, don't need to know that part. Basically, you need to know that lines are mapped to lines, angles stay the same, all that kind of stuff. Okay, and line lengths stay the same when it's reflected, etc. Go ahead and move into your exit ticket in Galileo, and then your reflection. And if both of those are done, please work on your Moby Max and your extra credit Prodigy.